Hi, folks. Um, New topic time. This time we're going to move on to a topic called similarity. When we talk about shapes being similar to each other, it really just means that they're the exact same shape as each other, but they're a completely different size. It means their dimensions have been either increased or decreased at the exact same rate. If you don't increase the dimensions at the same rate, then it ends up being either a distorted shape or a shape that's not a direct enlargement of the other one. So if a shape is similar, it means I've just taken it and increased the dimensions by the same bit so that I'm just getting a directly bigger version of the shape that we have. So to do this, what we're going to look at a formula here for it. Okay, and don't tend to think about the formula trying to learn it because it will come naturally to you just as you go through the process. Before we talk about the formula, let's have a look at a picture representation of what I mean. Okay, so here we've got my pet liger called Cuddles. Okay, he lives out the back. Took a picture of Cuddles, and there it's there on the screen for you to see. If I want to make a similar enlargement of that picture, then as I said, it means I want to take the length and the breadth and increase it at the same rate. And you will have seen this if you've been creating pictures on Microsoft Word using objects. If you drag a picture diagonally, then automatically it creates a similar shape. It means that the picture is the exact same lovely picture, but it's just bigger, or I can make it very, very small. Okay, so the dimensions are going to remain constant. They're either increasing or decreasing at the same rate. An example of a picture that's not similar would be this, where the picture of poor Cuddles has been stretched out of all proportion. So the length has dramatically increased, but the breadth hasn't increased, it's actually decreased. So it creates this horrible distorted view. Okay, so you would say that this object at the bottom is not a similar enlargement of the picture at the top. Okay, so when we go to calculate similar objects, we want to talk about getting a scale factor. And to get the scale factor, all we do is just think about it as being the length in the new shape divided by the length in the old shape. Okay, that's what gives us the scale factor, and we'll call it SF for short. And then to work out what the missing length is, we just take that scale factor and multiply it by the old length. Okay, you'll know what's the new shape and what's the old shape. The new shape is where your variable is going to be. The old shape is the one that's got all the dimensions in place. Okay, this will make far more sense when we do an example. Okay, so let's look at example one then. So it says the two picture frames below are similar. A mathematical question will always say that the objects are similar. It will always declare it for you. So that's your clue to use similarity. So we've got the old picture and the new picture. The smaller picture is the new picture because that's where the variable is that we want to work out. So the big one is the old one, the new one is the smaller one. So first thing I want to do is work out the scale factor. So I can say the scale factor is going to be new over old. So it's going to be new over old. So before I do that, before I work out what x is, we need to go to the sides that we know things about. Well, I know about the 25 and the 10. So go to the new object, so it's going to be 10 over the old length on the old object, which is 25. So 10 over 25, simplify that down, and you just get 2/5. So that's us done the first bit, working out the scale factor. Next bit is to work out the length, and the length is just the scale factor multiplied by the old length. So the length we're calling x, I can just say that x is going to be equal to the old length, which is 15, multiplied by 2/5. So really all I'm doing here is working out 2/5 of 15, which is going to be 6. So it's going to be 6 centimeters. Okay? So the scale factor is always new over old. Work out your scale factor and then multiply it by your length to find out your new missing length. Example B here, it says below is a pair of similar triangles. So find where the x is, that's going to be the new shape. That's going to be new, that's going to be old. So I can say that my scale factor straight away is going to be new over old. So go to the dimensions that we know something about. It's going to be the 8 and 4. So that will be 8 over 4, which is 2. So this means that this is a times 2 enlargement. In the previous example, example 1a, it was a times 2/5 enlargement. Now, when we talk about enlargements and reductions, we never ever talk about dividing the scale factor. And I probably should have said that it's a times 2/5 reduction, not enlargement, because it was going to a smaller shape. But when we talk about enlarging or reducing shapes, we never ever divide by the scale factor. We always multiply by a scale factor. And it's important to realise here that if you multiply by a number bigger than 1, that always has the effect of making the number bigger. But if you multiply by a number between 0 and 1, not counting 0 and 1, that always has the effect of making it smaller. So that's why when I said 15 times 2/5, that's really 15 multiplied by 0.4, which gave me the 6. So we always talk about multiplying by scale factors, never dividing. So here we've got a 2 times enlargement. So we go to the shape that we know something about. So it's going to be the 4 to the 8. So I can say here that the value of x is going to be the scale factor of 2 multiplied by the old dimension, which is 3. So it's going to be 2 times 3, which gives me 6. So that'll give me 6 centimeters. And that is finding missing lengths in similar shapes.